So hello everyone. So today we are going to discuss about data structures in Python, and precisely we'll focus on list. Right. So a data structure is nothing but a logical arrangement of data. Right. So we are going to organize our data, which may be collection of integer, float, strings, whatever, and we are going to impose certain rules on it that will restrict us from how the data can be arranged, modified, and accessed. So we'll put some rules that will dictate how the data. So based on these rules, we'll have certain extra features. Now data structures are very much important in computer science, right? So in higher classes there are usually papers dedicated to data structure. So data structure, another important aspect of a data structure is that it is usually for temporary storage, right? Provides some sort of an efficiency and some sort of an ability, right? So we are going to discuss about inbuilt data structures in Python and user defined data structure. So inbuilt data structures are already defined by the Python programming language, so we don't have to set any rules or write any kind of a coding to attain that particular data structure. All we have to do is just simply use it. It is already there, right? So we are going to discuss about list, tuples, sets, and dictionary and strings, right? So in this we are going to focus on list, and we will look into the remaining one later on. So now we also have user defined data structure, stack, queues, and trees, right? Where stack and queue are linear and tree is non-linear data structure. So to construct these kind of a data structure, which again has certain rules imposed on them, so to impose those rules we have to actually write Python code, but in case of inbuilt we don't have to. Now the first thing that we are going to discuss is about list. Now list is just a collection of element. List, okay. So list is just a collection of element that is stored within square bracket. So if we put a collection of elements within square bracket, it becomes a list. Now by default, if you don't put any element in it, it's an empty list, right? It's an empty list. Now if I put some numbers in it, maybe in 3, 4, 5, right, something of that sort, 24. So now this is a list of integers, right? And if we put elements of different type, right, maybe 1, then hello, 3.14. Now this is a list of heterogeneous element, right? So does it make sense? So again, when we put a collection of element within square bracket, they become list, right? So certain features. So first, enclosed within square brackets, right? This is the first. Next, it is mutable. Mutable, in simpler terms, it's basically editable, right? So editable in place. This is an important thing, in place, right? So if you want, you can change this hello to something else, or you can change this 4 to some other value. It is allowable. Okay, next is that there is no size limit, right? So that means you can store as much data as you want, and again it's not precisely true, because you cannot store infinite data on a finite machine, which is a computer. We cannot store any kind of an infinite data, right? And there needs to be no order of data, right? So they don't have to be an increasing or decreasing order. We can just randomly put data into it, and again it can be of homogeneous or heterogeneous type, right? So does it make sense? So now we'll talk about how to create a list, and we'll jump over to Jupyter Notebook. The first thing we are going to discuss is about creating a list. So we will declare a variable ls, something of that sort. So now we have created a list of integer. Now I'm sure that whether it is a list or not. So we'll type we'll check the type of ls, right? And if we execute it, so definitely we can see it's a object of class list. That means it's a list, right? Now let us create different kinds of list. So now this was a list of integers. Now we can also have a heterogeneous list. If I write something of that sort, so maybe 12, then and 4.58, something of that sort. Now this is a heterogeneous list because it has a collection of integer, a string, and a floating point number even. Now it's just a collection of integers, so that is an homogeneous list, and this is a heterogeneous list, right? So we can also create something called as a list of list, where we are going to put a list inside of another list.
So maybe something of that sort. So I can put within inverted comma a, then I can put a comma, another thing called as a b, and we can also have something of this sort, right? So here it's a list of list. Why? Because 12 is an integer, whereas this one is a list inside of a list, right? So again, it's a heterogeneous data structure, right? Fine. So now let's talk about something called as a dimension of a list. Now we can have list that is basically one dimensional list, right? So if I have something of that sort, ls is equal to 2, 3, 10, 24, right? It's a list. Now it's a one dimensional list. Now in simplest form, what it means is that only one index value is required. Right. That means we'll talk about index, don't worry about it. That means only one value can be used to identify each and every element. But if I have a two-dimensional list, imagine ls, which is consisting of other list, maybe 1, 3, 4, comma. So 2, 5, 7, something of that sort. Now this is a two-dimensional list because two index values are required. Right, two index values are required. So let us see how a two-dimensional array looks like. It's just like a matrix. So if you are familiar with it, 1, 3, 4, 2, 5, 7. Right. So it works somewhere around a matrix. So we have 0 and 1, which are the rows, right? So 0th row, 1 row, and we have column. Again, in computer science, everything starts from 0. So 0, 1, and 2. So we have 0th column, first column, and second column, right? So now let's see how it's two-dimensional list is being constructed. So again, I can declare ls2 is equal to a list within which we are going to create two more lists. So 1, 3, 4. So this is one of the list, and we can just go over there and construct another 5, 6, 7, 8. Right? Does it make sense? Now if I want, I can print it down. Print ls of 2. Right, so that is how we create a two-dimensional list. So this was an example of one-dimensional list, whereas this is an example of two-dimensional list. Again, in one-dimensional list, only one index is required to get the value, and in two-dimensional list, we need two indexes to get it, right? So now the next thing that we are going to talk about is accessing a list, and here we are going to talk about the index values, right, that we discussed earlier. So you see, accessing list elements, right? So imagine I have a list 1, 2, 3, 10, 5, something of that sort. These elements are in here, right? So if I just simply write print ls, so what's going to happen? The entire list will get printed, right? Which is maybe something we want at certain times, but imagine a scenario where I don't want the entire list to be printed, but only the element 10, right? Now to attain that, every list has something called as an index value to it. So now you can imagine index value to be a seat number in a bus. So you see, to avail a particular seat, you need to have the seat number. Similarly, Python allows two kind of index values. So if I write it over here, maybe 10, 20. So I have 4 elements in here. So Python allows two kind of indexing, that is positive index. So in case of positive index, it starts from 0 and progresses from left to right. So 0, 1, 2, 3, and it will keep on going. And it also has something called as a negative index, right? So it starts from right and all the way it goes to left. So -1, it starts with -1, -2, -3, -4, and it keeps on going, right? So this was positive and negative indexing in a 1D array. So does it make sense? Again, let me repeat. So positive indexes always starts with 0, negative indexes always starts with -1. right? So now if we talk about two-dimensional list, again let me reiterate. So if I have certain values in here, then again we have two indexes for rows, so 0th row and first row, and again we will have three indexes for the column, so 0th column, first column, second column. So does it make sense? So then we are going to look into it. So imagine I'll create a list. ls is equal to maybe 29, 30, 67, something of that sort. Does it make sense? Fine. Now we can access a particular element. So if I write print ls, then what's going to happen? The entire list gets printed. At certain times we want a particular element, maybe 40. So what is the index value of 40? Again, we remember that it starts from 0. So 0, then 1, and then 2. So the index value is 2. So we are going to write print ls of 2, and we'll execute. So obviously we are getting 40, right? So does it make sense? So always remember that indexes has to be provided in square bracket, right? So this was all about 1D list, one-dimensional list. Now we can move this idea to a two-dimensional list also, right? So this was about positive index. So we'll also talk about negative index right over here. So imagine I want to print again 40, but now this time I want to supply negative index, right? So what we are going to do, we will count from here. So 67 is at -1 and 40 is at -2. So all right, print ls, and it will be at -2, right? And if we execute it, as we can see, it's giving me 40. So it works both the way. I can use either negative index or a positive index. Both will work for us, right? Okay, so this was all about one-dimensional list. We will move over to 2D list, right? So let us create another list. ls2 is equal to, which will be again a list inside of a list. So maybe 10, 20, 30. Doesn't matter, the order doesn't matter. We do remember 40, 50, and 60, right? Now if we try and print it, let's see what happens. Print of ls2, right? So as we can see, we have the couple of numbers in here, right? I'll comment out these prints because then it will be more understandable, right? So we have these elements in here. So imagine I want to get this element 20 to be printed. So we have to use two-dimensional indexing, that is row and column. So that means this is the row 0 and this is the row 1. So if I do something of that sort, print ls of 1, what it will give me? Sorry, not ls, it will be ls2, right? So we can see the entire row is being given to us, right? But we want this particular element 20 in it. That means we are on the right row, but then we have to filter out the column also. So this is the 0th column and this is on the first column. So we are going to write 1, and as usual we are getting our element 20. So does it make sense? Now if you follow the blog, so in blog we have talked about the positive index and negative indexing on a list of 4 elements, right? It can be mapped to as much size as we want. And here is a code example where we are using positive index, negative index, and we are also using two-dimensional list to get a particular element, right? So we are using a row column indexing to get a particular element. Fine. Now the next thing that we are going to do is use a for loop to traverse. So let us construct a for loop. So imagine I'll go through the similar kind of a code. So we have the one-dimensional array, that is ls. So I can write a for loop on it. For I in ls, we can print I, right? So now the thing is that I will have each and every element of my ls. So if I execute it, as usual, we can see all the elements, that is 29, 30, 40, 67, 29, 30, 40, 67, right? So this was using a for loop to access a one-dimensional array. Now imagine if I want to do the same with a two-dimensional array. So let us just change it to ls2 and let's see what happens. Now we see that it's working, but I in this case is holding each and every row. It is not having each and every element. So in that scenario, we have to use something called as a nested for loop. So for j in I. Does it make sense? Now why j in I? Because j will actually have all the rows, right? Now we are going to traverse on that row itself to get each and every element, right? So then we will put a tab, and obviously it is going to be j. Does it make sense? And now we'll execute it. So as usual, we can see all the elements, that is 40, 50, 60, 10, 20, 30. So does it make sense? So we talked about using loops for accessing all the elements of a loop. Whether it is one dimensional or two dimensional, both can be accessed via a for loop. The next thing that we are going to talk about is adding or appending element to an existing list, and we are going to talk about certain functions. This is append, extend, and assignment, right? Fine. So we'll create a list. So ls is equal to, maybe I have a couple of elements in here, 23 and 24. Two elements are there. So if I want to add another element, I can use the append function. So ls dot, let me print it first, print ls. So as usual, we can see two elements are there in the list. So I'll try and append it. So ls dot append, I want to append maybe 24, that is add 24 to it, sorry 25. So print ls. So now we can see the element 25 has been added to my list. Now the interesting thing to note in here is that append function always adds the number to the end of the list, right? So that is how it works. Now the next function that we are going to discuss is extend. So it kind of adds two or more lists together. So if I create another list, ls1, again it has collection of element, maybe 26 and 27. It has two elements in it. If I write ls dot extend, and it is ls1. So it's working fine. What we are going to do, we are going to print to see what is the present state of the ls function. ls list, okay, yeah. Now we can see the condition of our ls, that is the new elements from another list, that is ls1 has been appended to it. So we have seen two functions, append and extend, right? The next function that we are going to see is called as an insert. So insert allows us to insert a particular element in a particular location. Now in case of append or extend, everything was being added to the end of the list. At certain times we might not want that. So imagine I want to add hello in here. So 0, 1, I want to add hello at index number 2. So I can do that. ls dot insert. So insert function takes two arguments. The first one is the index value. So maybe I want to add an element to index value 2, and then I'll put just hello in here, and then I'll write print ls. Now as usual, now we see that okay, hello has been added to the index number 2. Now the interesting thing is that it doesn't overrides. It has not overridden 25, which was at index 25, which was at index 2, right? So what it does, it just creates a space and insert the value, right? So this is how these three functions work: append, extend, and insert. And also we can use assignment operator. So imagine if I do that, ls, and within square bracket is required. So at index number 2, I want to add something like hello there, right? Now if I execute it, but I'll also write the print statement to see what's inside it. Fine. So now we can see that hello there has been replaced with hello has been replaced with hello there. So now this is how assignment operator works. as contrast to an insert statement, which would insert an element and just keep all the existing element, but in case of an assignment operator, it will just overwrite the position where we want it. So does it make sense? Fine. So this was all about adding and appending element. So the next thing that we are going to talk about is removing an element from the list. So for that we are going to use two functions, that is del and pop, right? So we have two functions in here. Move over to our coding section. So again, I'll create a list which will have a couple of elements, maybe 10, 20 and 30. So imagine if I want to remove an element from it, I can just write simply del, from where I'll write from ls, and within ls we'll write the index. So suppose I want to remove 20 out in it, so the index of 20 is 1, and then I will print ls. So as we see, 20 has been removed, right? So this is one of the way to do it. Next thing that we can use is a pop function. So ls dot pop, and then the item that you want to remove. So maybe I want to remove the item from position 2, that is, it will remove 13 here, and then obviously I'll print my final ls, right? And let's execute it. Yes, it is still out of the range. Why? The thing is that we have already deleted it, no? So we have already deleted 20, so this is not the list that we are talking about. If you want to use this list, we have to redefine it in here, only then it will work. So that's why it was saying that pop is out of range. We have to remember we cannot delete something that is not there, so it's important that way, right? So now we can see that at index 2, 30 was there and 30 has been removed. Now the difference between a pop and a del statement is that del just simply deletes an element from the list, whereas pop will delete or remove the element as well as return the element. So imagine you are constructing a stack out of a list. So in that scenario, so you remove an element from the top of the stack, at the same time you also use the element for any purpose you want, right? So if I just try and print it, the 30 is being returned also. So we can get hold of the element that is being deleted, but this is not possible with the del. So does it make sense? So this was all about removing an element. The next thing that we are going to talk about is operations on a list, right? So first we'll try and join to list. So if I have ls, which is a list of numbers, because numbers are easier to type as compared to putting strings, ls2, right? So we have to list. Now if I want, I can use a concatenation operator or plus operator. So ls plus ls2, right? And if I execute it, so we can see it has actually joined two lists together, right? So this is about joining of a list. So example is being given and a bit of remarks is also written. So go through the blog post for the theory part. Now I can also use a multiplication operator to replicate it. So we discussed about it when we were discussing about arithmetic operators. So if I want to replicate ls maybe 5 times, so we can see what will happen. The same element of my list ls is getting repeated 5 times. So does it make sense? So this is these are two operations, that is joining and replication. The next thing that we are going to talk about is very much important. So slicing, right? And we'll also talk about something called as a striding. Now these two topics are very much important from the exam perspective and obviously from understanding of list as a whole, right? Now imagine we will declare some list ls maybe 2 or ls3, which is equal to a couple of elements, maybe something of this sort. Now we have seen how to print the entire list, and we have also seen how to print one of the elements from the list using an index. Now suppose this is not what I want. I want to get couple of elements, maybe 4, 5, 6 from this list. So in that scenario, one single index is not going to happen. And again, it's not a good idea to put, maybe you see, 5-6 lines to get this. I'll comment the previous code. Right now, using slicing, we can slice our list. So how slicing work? So obviously we'll print it, print ls3. Now in here, within the square bracket, we are not going to provide one single index, we are going to provide a sequence. So we are going to print from 4 to 6 onward, right? So 0. So what is the index? That is starting index of my slice. So 0, 1, 2. So 4 is at position 2. Then we'll use a colon to separate it, and then 2, 3, 4. So we want to go to 4. Let's see what happens if I put 4 in it and if I execute it. Okay, so there is a slice, but not what we want. So 6 is not included. Now we have to understand this particular extreme point, that is end index, which is 4, is not included, right? So it's 4 minus 1, that is up to 3 is included. So if I want to print 6, which is at index number 4, I have to increment it to 5. In that scenario, we can see we are getting it 4, 5, and 6. Now this is the idea behind it, striding. So you see the syntax is, we'll have the name of the list, then the start index, right? The position from where we want to start, then a colon has to be there, and then the end index. And remember, end index is not inclusive. That is, end index minus 1 will be included, right? So does this make sense? So next we will move over to something called as a striding. So I'll comment out the previous code, and I'll use the previous list itself. So it is not required, it's already there, but just for the sake of consistency. Now what striding allows us to do, we can get a slice or maybe the entire list, but if I want to jump on particular elements, right? So if I want to escape particular elements in a pattern, then striding can be used. Now striding has 3 arguments to it. So if I want to do that, print. So imagine I want to print all the elements in the odd position, right? So obviously I'll name ls. It will start from 1, sorry, it will start from 0 and go all the way. How many elements are there? So here we have 8 elements, right? So I'll go up to 9, because if I put 8, it's not going to work, right? And then we'll add 2 to it. Let's see what happens. So we are not going to use ls, right? We are going to use ls3. And as usual, all the elements at negative positions are being included, right? So now we will try and understand how it's actually working. What's the logic behind the code? So first we will describe about striding, right? And after that we'll discuss about slicing. So you see, striding basically takes 3 arguments, right? So we have the name of the list as usual, then we have a start, right? Then we have a stop index, and then we have some sort of a, you see, jump index, right? So if I have something of this sort, so I have an ls list which have certain elements 10, 20, 30, 45, maybe 60, something of this sort, right? Now if I want to print it, if I write this code, print ls. Now ls starts from 0th index, so I'll write the index position 1, 2, 3, 4. So I'll start from 0 colon, and I'll go all the way up to 5, because if I put 4, 4 doesn't get included, we understand that. And after that we'll put 2 in it, right? So what does it mean? So it will obviously start from 0, so ls of, so let's not put 2, let's put 1 in here, and let's see the behavior. So it will start with 0, ls of 0 is 10, it gets printed. Now this 0 will be added to 1, so I'll have ls 0 plus 1 is 1, so at 1 position we have 20, ls of 2 becomes 30 because 1 plus 1 is 2, and in this way it keeps on going till we get 60, right? Now if I just modify this piece of code, print ls of 0, 5, 2 in it, right? 0, 5, 2. So now as usual it will start from ls of 0. ls of 0 is 10, gets printed. 0 plus 2 is 2, that means at position 2 is 30. 30 gets printed. Now 2 plus 2 is 4, so ls of 4 is 60. ls of 4 is 60. So now we are getting all the elements in the odd position. Now this is the idea of striding. Now we can see slicing is a kind of a variation of striding, where 1 is by default the jump number, right? So does it make sense? So slicing is just a variation of striding. So in case of slicing, right, we just have two numbers, that is start index and stop index, and here we don't provide a jump, right, because jump is by default 1, so we don't need to provide it, right? And this will provide us a slice where every other element is printed within the slice. So does it make sense? Okay. So the next thing that we are going to discuss is about some of the common functions in that can be used on a list, right? So now index, I'll just not write the code, I'll just simply explain it from here. Index, you can just visit the blog post for just the theory part. So index will return the index of the particular item, the first occurrence of the item to be precise. So 67, the index is 2, so that's why 2 gets printed. Clear function actually removes all the element from the list. So 23, 45, 67, 89 gets deleted, and we have an empty list here, right? Now count will count the occurrence of a particular element. So you see 34, we are trying to count the occurrence of 34. So this is the first, second, third and fourth occurrence. So that's why the output is 4. It always gives you an integer number, right? So the next thing that we have is reverse. Now what reverse does? Reverse will just flip over the list. So the last element becomes first element, and the first element becomes last element. So 22.5 is the first element of the list. So does it make sense? Now sort function is very much important. Now at certain times, just like this list that we have in here, which is unsorted, right? So 1 is in the middle, 78 is next to it. So if I want to arrange it in an increasing order, then we can use the sort function. What sort function will do? It will arrange everything in an increasing order. So 1, 3, 5, 8, 4, 55 and 78. Now by default, sort function will arrange everything in ascending or increasing order. But if you want to do it in the reverse, that is, we want to get in a decreasing order or descending order, then we are going to write reverse equal to true. That is, sort within parentheses, we are going to write reverse equal to true, and it's gonna reverse, right? Okay, fine. The next thing that we are going to cover is list comprehension. Now list comprehension is very much interesting as well as powerful, but it is not mandatory. We can do the same thing using a for loop. That is the interesting part about it. So it's just basically using a loop to construct a new list. So that is the idea behind list comprehension. From an existing list, we are going to create a new list, but by default, usually we use a for loop for that. But in that place, we can use list comprehension style. So it's just a modified way of writing a for loop. So let's see how it works, and then I'll explain it. So imagine I have a list which is at present empty. So if I want to maybe put 10 elements in it, how we are going to do? We are going to use a for loop for I in range of 10. We are going to use the append function, that is ls dot append I, right? And after that, we are going to use the print function, print I, not I, we are going to do print ls. And if we do that, so we can see we have 10 elements in here. right? It should not be operations on list, it should be list comprehension. Jump out of it. If I execute it, so I have all the elements that are being done. Now this is one of the way by using for loop. We can do the similar thing using list comprehension. So how list comprehension does? So we can just do the entire thing of these 3 lines of code in one single line of code within square bracket, because we're creating a list, so obviously square bracket. So this part goes first, I, so it will be here first, so I, then the follow for I in range, which is a function range of 10, and we'll just simply print it, print ls, right? So similar behavior. So that's an idea behind list comprehension. So basically from for loop we can derive a list comprehension. Now the interesting thing is that you see all the list comprehensions can be done using for loop, but the other way is not true. That is, not all for loops can be converted into list comprehension, right? So now it's not the only thing that we can only put a for loop in it. We can also put conditions in it. So imagine I want a list of maybe even numbers. So how we are going to do that? Again, we are going to create an empty list. We are going to demonstrate using a for loop. For I in range, I want to get 5 integers, so I'll put 10. I want to have 5 even numbers, so I'll put the range 10, because within 10 numbers we can have 5 even and 5 odd. So we are going to check if I modulo 2, right, that is, we'll find the remainder which is equal to 0, that means it's an even. Then what we are going to do, ls dot append, we are going to use the append function I, right, and then we are going to print it to see our list, print ls, right? So as usual, 0, 24, 68, 6 and 8, these are all the prime numbers that we have. Now again, if you don't want to include 0, it's possible. We can just start from range 1 all the way to 10, still it will work. Now let's try to attain the similar behavior using list comprehension, and we can see how much compact the code will become. ls again within square bracket. So this will obviously go first. I will go first here. So I, then the for loop for I in range, I've missed 10, I've missed in here, I'll do that, for I in range 10, then the if condition, if I modulo 2 is equal to 0, right? So we are done here. Then we'll print ls and let's see how it turns out. So we can see the similar behavior, right? So does it make sense? So in here, again, we can put conditional, we can even put nested for loops for list comprehension. But at certain times, we should not put hugely complicated for loops into a list comprehension, because everything you see should be understandable later on. So for the code friendliness, we should not use list comprehension on an overkill. So does it make sense? So again, in the blog post, we can see that the benefits is that it is easy and compact. Conditional statement can be used. Obviously, nested for loops can be used. Complicated loops should not be written in a list comprehension, as it is not user friendly. Now this point is important. So at certain times, we should not go on an overdrive and try and convert each and every nested for loop into list comprehension, right? And another important thing is that obviously you see each and every list comprehension can be written using a loop, but we cannot convert each and every loop into a list comprehension. So in here we can see certain variations where we have used you see a normal for loop, then we have also used exponents, we have also used conditional statement, right? Now we will talk about how actually a for loop is being converted into a list comprehension, right? So we'll have our for loop. So imagine we have our list which is empty, then for I in range of 10 maybe, because we are writing the program to find all the even numbers, right, within 10. So if I modulo 2 is equal to 0, then what we are going to do, ls dot append I, right? Now we'll try and map it to a list comprehension. So how do we do that? ls is equal to within square bracket, because list comprehension always starts with a square bracket. So we'll write I first, I, then the outer for loop. So for I in range of 10. So no colon, no nothing will be required in a list comprehension. Then we'll write the condition in here. If I modulo 2 is equal to 0, and then we'll close the square bracket. So does it make sense? So this comes in here. This outer for loop is here, and this is my conditional statement. So this is how a for loop is being converted into a list comprehension, and obviously because we can also go back in this side, that is from list comprehension we can create a for loop also. So this was all about data structures and introduction to data structure, as well as basic introduction with list, right? So go through the blog post and try some more problems and questions so that you understand it well. I hope you enjoyed the video and subscribe to the channel for more. Thank you for watching.